Position time graphs. All right, so that's what we're going to be focusing on. You ready, Alan? You good?
I have a question on forces.
On forces? We'll get to that after this. All right, position time graph. So I'm just going to create a position time graph here so everybody can see it. Okay. So time is down here. Position is over here. Remember, we treat position time graphs the exact same as we do displacement time graphs, okay? So everything is exactly the same, whether it's position time or displacement time. Okay, so I'm going to use different colors, so I want you to kind of follow along with me. Now, anytime on a position time graph, okay, anytime it is going to be going up, all right? So for example, the line looks like this, okay? Do you see how the slope of the line is up? It's toward the positive. Anytime that happens, it's going to be going forward, no matter what, okay? So like, for example, this one is going forward, so we're going to just put an F over here for forwards. And then what can you tell me about the acceleration of it? First of all, what can you tell me about the velocity of it? Position time, what can you tell me about the velocity of it? Bingo, it's constant, okay? So if it's forward, it's going to have a constant velocity. One. And what's its acceleration? If it's a constant velocity, the acceleration is what? 0, okay? So in this example, if it's going forward, the velocity is what? Positive. And my acceleration is 0. Does that make sense? Constant velocity going forward. That's one example, okay? That's one example of how something could be going up, positive slope, and still be positive velocity, 0 acceleration, because that's a constant. Now, there's a couple other ways we can look at this. I can look at something like this. Okay, do we see the bend there? Okay. Do you see this bend? Does anybody know what that bend represents? It represents a change in velocity, okay? First of all, is it going forwards or backwards? Yes, because we still went up, all right? We still have a positive of the slope. So we're going forwards. I'm just going to use an F to show you the forwards. Now, here's a question for you. It's going forwards. Is it speeding up or is it slowing down? Slowing down. Anytime it bends to the horizontal, it's going to be slowing down. So this one's bending horizontally, so it's slowing down. So what do I know about the velocity? If it's going forward, the velocity is what? Positive. What do I know about the acceleration? If it's slowing down and the velocity is positive. It is a negative acceleration. Anytime these are different, velocity positive, acceleration negative, velocity negative, acceleration positive. Anytime those are different, it's slowing down, okay? You're going to see trends starting to pop up here. Okay, so there's 2. Let's do another one. Let's go with this blue right here. All right, so I have blue. What about this one? Is it speeding up or is it slowing down? First of all, is it going forwards or backwards? Forwards. Why? See how it's still increasing upwards, so it's going forwards. Now, is it speeding up or slowing down? Speeding up. Good. Since it's not bending horizontal, this one is bending vertically, okay? This one is bending vertically. Think about, like, top thrill dragster at Cedar Point. You got to speed up a lot to get up that hill, right? Okay? That's what we're talking about here. This is at the top of the hill where you slow way, way, way down. Here, you got to speed up quick to get up that hill. So here, we're forward and we're speeding up. So, what's my velocity? What's my velocity? Positive. Good. My velocity here is positive. It's positive because I'm still going forward. Still going forward, okay? Now, what's my acceleration if it's speeding up? Also positive. Excellent. Okay, also positive. Excellent, excellent, excellent. All right, let's continue on. Let's start looking at it a little different way this time. I'll go to this red here. Go to this red right here. All right, so now let's do this. Now we're going to do this. Now are we going forwards or backwards? Backwards. Notice how I'm here, okay? And that slope is a downward slope. Now we're going backwards. So my red is going to be backwards. What do I know about the line? What is my line representing? A straight diagonal line represents what?
No constant.
Constant velocity. So we're good. We're constant velocity. So my velocity, is it positive or negative? Why? Yes, it's negative because we're going backwards. I know we're going backwards because that line is sloping downwards. If the acceleration is, if the velocity is constant, what's my acceleration? 0. Good. Bingo. Okay, good. Let's do another one. Let's go to, we'll use pink. Okay, I'm going to dirty this up here real quick. So I'm here. Guys, we're almost out here. Let me just finish up. That right there represents what? Is it bending horizontal or is it bending vertical? It's bending horizontal. Good. So this is backwards, slowing down. So my velocity is negative. My acceleration is, if it's slowing down, it needs to be what? Positive. If it's slowing down, it has to be positive. Okay? Since it's slowing down, it has to be positive. And then last but not least is going to be this one. Okay? Okay, this one right here. Now, see how that one's bending vertical? Okay, so this one is backwards, speeding up. So my velocity would be negative because it's going backwards. My acceleration has to be the same as my velocity, also negative, okay, because it's speeding up. And then last but not least, what about this one? What's this one showing us? The black line. What's the black line showing us? Is it moving forwards or backwards? No. Is it moving at all? No. So my velocity is 0. My acceleration is 0. It is at rest. Make sense? Okay. Hopefully that's a little crash course for you.